Graphing systems of inequalities. We need to recall some of the shading rules. Remember, if it's greater than, it's going to be a dashed line and you're going to shade above. If it's greater than or equal to, you're going to have a solid line and shade above as well. If it is a less than symbol, it's going to be a dashed line shading below. And if it's a less than or equal to, it's going to be a solid line shading below as well. Don't forget, if you're going to multiply or divide by a negative, you need to flip the inequality sign. Your answer for these is going to be where your shading overlaps. Now in our first example, both of these have to be in y equals, which the first one is, but the second one is not. So we need to put this in our slope-intercept form. So we're going to have our final answer is y is going to be greater than or equal to 1 over 3x minus 2. So we're going to graph the first one. So here we're going to have start at positive 3, and we're going to go down 2 over 1. And then we have our dashed line here. And shading everything below. Now on the second equation we have negative 2 up 1 over 3. And we're going to have a solid line here. And shade everything above. So the area that both of our shading overlaps is going to be in this general region. Now in the second one we have x is going to be greater than negative 2. So we have a vertical line that's dashed that goes through negative 2. And it'll be everything greater than, so we shade to the right. Now y is less than or equal to 1. We have a horizontal line that's solid and shading everything below. So in this general region is where both of them overlap. Now our next equation, both of these need to be in our slope-intercept form. So for the first one, we're going to have y is going to be greater than 1/2 x plus 2. Our second equation is to be y is less than 1/2 x minus 3. So the first one we start at positive 2 and go up 1 over 2. And we'll have a dashed line through here. And shade everything above. On the second one we start at negative 3 and our slope is 1 over 2 as well. Another dashed line. Now we need to shade below here. Now since our shading does not overlap, we actually have a no solution for this one. Now in this one, we have this one slope-intercept form, but here we have an absolute value that's less than a 3. We have to write it as a compound, so it'd be negative 3 less than or equal to y, which is less than or equal to 3. So in the first one, we're going to start at the y-intercept, go up 1 over 1. We have a dashed line, shade below, and then our compound through negative 3, we're going to have a solid line, and then positive 3, another solid line, and we need all the shading in between. So our solution is going to be in this region here. Now our last one, we want to find the vertices of the figure drawn. So we need to put all of these in slope-intercept form. This one's fine, but this one over here is going to be y is less than or equal to 1 over 3x plus 4. Then our third equation is going to be y is greater than or equal to negative 4 over 3x plus 4. So we have x is less than or equal to 3, so we have a solid vertical line. And shading to the left. Everything less than. Now up here we have our positive 4, and then up 1 over 3. So we're going to have another solid line here, and shading below. And then we have a positive 4 again, then down 4 over 3. So we're going to connect these 2 points and shade everything above. So what happens is in this area here, all the graph of the shading is going to overlap. So these 3 lines actually create this triangle that we need to find the vertices of. So the first one here is going to be 0, 4. One down here is going to be 3, 0. And then we have our 3, 5. So these are the vertices that make this polygon. And that is it.